So we're going to talk a little bit about simplifying trig expressions. So again, this is something that we did earlier in the year and we are coming back to it now. So I'm just going to do an example. A couple things to remember. First of all, theta, you'll remember from before, is just a variable. During most of the Desmos activities, you'll see an x instead of a theta. In the homework, you might see other variables. It's just a variable. It's just an unknown. You need to write it though, so you can't write secant without a theta. So sometimes as we start to work, we get a little lazy, we move a little quickly. It's not correct. And also, Desmos won't be able to check your work for you if it's not written with the input there. So it has to be secant and a variable. Like I said, on Desmos, it will mostly be x. In other things, it could be different variables. The other thing to remember is that when the functions are written just next to each other like this, they're being multiplied. So the secant of theta is being multiplied by the cotangent of theta is multiplying by the sine of theta. Again, when we're using Desmos, we're going to need to put parentheses around here, or else Desmos won't know what we're talking about and it won't be able to check our work. So when you're working in your homework, when you're submitting things separately off Desmos, you can just write them next to each other. But whenever you're using Desmos, you're going to want to put parentheses again so that it can check your work. So now I'll just go over an example of how we would simplify this. So we have all of our identities, which are on the page. But here they are also. Here's my reference sheet. It might be a little blurry, but what I have here is that secant x is equal to 1 over cosine x. So I have a theta here, I have an x here, but all it's saying is secant of any input is equal to 1 over cosine of that same input. So these two things just have to match. They could be a single variable, they could even be more than a single variable. So I know that the reciprocal of secant is 1 over cosine. Now the reciprocal of cotangent is 1 over tangent. However, there's no other tangent here. A really good trick is to try to change everything to sine and cosine. So instead of using 1 over tangent, I'm actually going to go down to the ratio identity and use sine over cosine. That way, when I make my substitutions, everything will be in terms of sine and cosine, which is a really good trick if you're not sure what to do. So I'm going to replace secant theta with 1 over cosine theta. I'm going to multiply that by the ratio identity for cotangent, which is cosine theta over sine theta. And then sine theta I'm going to leave and put over 1. So my strategy here was to change everything in terms of sine and cosine. Now while you're working in Desmos, I'm going to have you justify some of your answers. That's only because you need to remember that everything you do, you can't just do whatever you want. So why was this okay? All I did was make substitutions of things that were equal. I used reciprocal identities and ratio identities. All right, the next step I'm going to do here is I'm going to multiply straight across. So again, everything's justified. I'm using my algorithm for multiplication that we learned in the beginning of the year. So I'm just going to multiply everything in the numerator, and then I'm going to multiply everything in the denominator. So 1 times cosine theta times sine theta is cosine theta times sine theta. Cosine theta times sine theta times 1 is just cosine theta times sine theta. So this is just the multiplication of fractions. And again, the justification isn't to make it harder. It's to make sure you're not just doing things that you're not supposed to be doing. You're only doing things that you know are going to work and are allowed to be done. Finally, hopefully we started to see here that we have some giant ones. Cosine theta divided by cosine theta is 1. Sine theta divided by sine theta is 1. And 1 times 1 is 1. Okay, so that's the identity property of 1. I'm not super concerned that these are perfectly written, just that you're taking the time to justify what you did to tell me why you were thinking that. That's also going to help me look over your thinking.